So here's a little tutorial on how to draw a line graph. So we'll start with the question. A car leaves KFC in Manlyvale and drives along Condamine Street in the northbound direction. The following table records the displacement of the car over time. So we've got our two variables up the top of this table here. So here's time in seconds, and we've got displacement in meters. So now remember, the first thing that you can do, and it's probably the easiest thing to do, is to write our labels on the axes. So time in seconds on the left, displacement in meters on the right. We read from left to right. You have to crawl, so your x-axis, before you walk, which would be your y-axis. So we go across before we go up. Crawl before you walk. So I'm going to write time in seconds down here, and I'm going to write displacement in meters on my y-axis. The next thing that's probably the easiest thing to do, notice that I've used the units as well. I've got seconds and meters there, and I've got seconds and meters there. The next thing that's probably the easiest thing to do is look at your graph and just write a title for it. So displacement over time. We're talking about a car here, so displacement of the car over time. Notice how this does sit over this. It's actually a nice way of writing a title. The next thing that we can do is draw a scale. So if we count, let's do our x-axis first. So we've counted the squares: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now we need to make sure that we get from 0 to 9 along this. So there's a couple of ways of doing this. The easiest is probably a little bit of trial and error. So we know we need to start at 0, make sure that it goes on a line itself, not in the space. If I go up in ones, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm only going to end up about halfway along my graph, which is a little bit too short. So I need to use a little bit more space, at least 80% of the graph area. So let's see what happens if I go up in twos, rather every second square is 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and I end up using a larger area of the graph. So let's put those in: 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's do the same thing for the displacement in meters. So our largest number is 72.5, our smallest number is 0. So I need to make sure that I can fit 72.5 along these squares. So let's count the squares again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I need to fit 72.5 in 20 squares. If I go up in ones, I'm going to get to 20. It's too small. If I go up in twos, I'm going to get up to 40, which is still too small. 3 is a little bit of an awkward number. I wouldn't suggest using it. It's probably better to go up in fours. If I go up in fours, I'm going to get to 80. Which is pretty close to 72.5, but gives us a little bit of room. So let's try that. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68, 72, 76, and then 80. So my largest number, 72.5, is going to sit about there. So I've got plenty of room up the top, but I also have used 80% of the graph area. The only thing left to do now is to plot the actual points, which we're going to do using crosses. So reading from left to right again, we're going to start with our time, and then we're going to plot the displacement. So I'm going to move my pencil. 0, 0 is an easy one to do. So that means there's a cross here at the origin. The next thing I'm going to do is, at 1 second, the car's been displaced 4 meters. So I'm going to go across with my pencil to 1, and I'm going to go up to 4 and draw a cross in there. I'm going to repeat that for the rest of these. So 2, 7.5 is probably somewhere up here. Halfway between 4 and 8 is 6. That would be 7. 7.5 is right near the top of that box, but it's not on 8. At 3 seconds, it's 12.5. So if I go across to 3 seconds, 12, now between 12 and 16 would be 14, which means 13's there. 12.5 is probably about there. If I go to 4 seconds, We need to go up to 18, same kind of deal. So 18 sits halfway between 16 and 20. After 5 seconds, it's 25 meters away. So there's 26. So 25 is going to be a quarter of the way up that square. After 6 seconds, it's going to be 35 meters away. So I'm going to follow this up. 32 and 36, 34 is in the middle. So 35 is in the middle of those two, 3/4 of the way up. After 7 seconds, it's 42.5 meters away. So there's 40, there's 44, 42 is there, 42.5 is in here. If I go to 8 seconds, it's 56 meters away. So that's an easy one that actually falls on the line itself. And if we go to 9 seconds, we're 72.5 meters away. So I'm going to follow this 9 line up. And I'm going to say, okay, well, that's 76, that's 72, that's 74, which means halfway there is 73. So 72.5 sits somewhere in there. And what I get is what now looks like a curve to me. This is not a straight line. If I were to put a ruler here, we can see that those points actually don't fit nicely on the straight line. You can see that they're a curve. So what you need to do to the best of your ability is actually draw that curve with your hand within reason. Don't join the dots. So we're going to draw a smooth curve, which fits something like that. Now, there is a little bit of room for error here. We do realize you are doing it with your hands. You're not a computer, so it's not going to be perfect. But what we don't want you doing is joining the dots. When you're finished your graph, what I want you to do is have a look at the little document we've left up here. It sits in that little graphing section, and it's got this little acronym Cutlass in there. So we've got to go through these and check that we've done these things. So have we used crosses to plot our points? Yes, we have. Don't use dots. Have I included units on the X and Y axis? Time is in seconds, displacement is in meters. Does my title include both variables? Displacement of the car over time. I should be able to see that that is reflected on my axes and this is reflected on my axes. I've used that term displacement and time in both. Are the axes both labeled? Yes, displacement and time. And is my scale appropriate? Does it take up 80% of the graph? Yes, it does. 0 to 9 uses most of that area, and 0 to 72.5 goes all the way up there. My graph is not stopping somewhere in the middle. The other thing to note is that each one of these is equal. So every 2 squares is 1. So 1, 2, 1, 1, 2, 2, 1, 2, 3. So all of the spacing up here is equal. I haven't done a 1 here and then gone 2 and done a 2 there. Each one of these squares is worth the same value. So I guess each one of these is worth a half going sideways, and each one of these squares is worth 4 going up. So that's how to draw a line graph.